Imagine stepping onto a planet where the skies do not bring water, snow, or hail, but burning droplets of molten iron crashing down endlessly. The ground trembles under the weight of each fiery drop, and the horizon glows red as if the atmosphere itself is forged inside a furnace. This is not science fiction, but a reality that astronomers have uncovered far beyond our solar system. Such a place challenges our very perception of what a world can be. We are used to thinking of rain as something refreshing, even life-giving, but here it becomes a symbol of destruction. Instead of nourishing soil, it scorches anything that dares to exist on the surface. A planet with such conditions instantly forces us to rethink what weather truly means. The human mind struggles to comprehend this level of extremity. Our imagination often stretches toward alien landscapes, yet this planet surpasses many of our wildest depictions. It is as if nature itself crafted a nightmare, hiding it among the stars for scientists to one day uncover. That discovery did not disappoint. The mere existence of such a planet fuels our insatiable curiosity. We cannot help but ask, how does this phenomenon occur? What makes it possible for iron to evaporate, travel across skies, and fall as rain on another part of the planet? The answers lie in a dance of physics and chemistry on an unimaginable scale. But before we unravel that mystery, we must first understand what world we are dealing with. This is not an ordinary rock, nor a gas giant like those circling our sun. This is something else entirely, a giant whose behavior challenges our models and forces scientists to invent new ways of seeing. Its skies are toxic, its winds are ferocious, and its heat is unbearable to any known form of life. And yet, despite all this hostility, it is beautiful in its strangeness. To picture it, imagine standing on the shores of a blazing ocean with rivers of iron streaking the night like molten fireworks. Such imagery might sound poetic, but it is based on real scientific observation. The data collected from telescopes confirms the unimaginable. Somewhere in the cosmos, a storm of iron truly rages, and the thought of it lingers in our minds, filling us with equal parts awe and terror. Every great story has a hook, and this planet provides one of the greatest ever discovered. Its environment is not only extreme, but also unique, unlike anything else known in astronomy. That uniqueness is why it has captured the attention of scientists worldwide. This is more than just a story about iron rain. It is about the fragility of our understanding, the limitations of human imagination, and the wonders that lie beyond our solar neighborhood. And to begin comprehending it, we must turn to the star of this cosmic tale, WASP-76b. So, prepare yourself to journey deeper into this celestial furnace, for in the next step, we'll uncover the discovery of this planet, its colossal size, and the secrets that make it a true monster of the universe. WASP-76b, discovery and main characteristics. The planet that astonished scientists with its iron storms is called WASP-76b. Discovered in 2013 by the Wide-Angle Search for Planets WASP project, it quickly became one of the most extraordinary exoplanets ever recorded. Unlike Earth or Mars, it belongs to a category known as hot Jupiters. Hot Jupiters are massive gas giants that orbit dangerously close to their stars. While our Jupiter takes nearly 12 years to circle the Sun, WASP-76b completes a full orbit in just under 2 Earth days. This proximity is what subjects it to such extreme conditions, turning it into a laboratory of cosmic extremes. In terms of size, WASP-76b dwarfs Earth. It is about twice the radius of Jupiter and significantly more massive. Imagine a planet so large that 1,000 Earths could easily fit inside it, and yet its environment makes even the concept of giant feel fragile. Its very nature radiates intensity. One of its most bizarre qualities is its tidal locking. Just as the moon shows only one face to Earth, WASP-76b always keeps one side facing its star. This means one hemisphere burns under eternal daylight, while the other remains in endless night. The result is a world of violent contrasts. The day side of the planet blazes at temperatures exceeding 2,400 degrees Celsius, hot enough to vaporize metals. Meanwhile, the night side is cooler, but not in a way humans could ever endure. It still simmers with temperatures hotter than most industrial furnaces on Earth. This eternal split sets the stage for its deadly weather. The composition of WASP-76b is no less fascinating. Like Jupiter, it is dominated by hydrogen and helium, but its atmosphere also contains heavier elements, including iron. These metals, normally solid and stable on Earth, behave entirely differently in the furnace-like skies of this planet. Its winds are another terrifying aspect. Gusts of supersonic speed carry vaporized materials from the star-facing side to the darker hemisphere. Among those vapors is iron itself, destined to fall as metallic rain once it cools in the eternal twilight. It is this movement that creates the iron storm we will soon explore. The sheer violence of the planet's climate makes it an object of obsession for astronomers. With every new piece of data, it challenges existing models of atmospheric science. What happens on WASP-76b may hold the key to understanding extreme worlds across the galaxy. Beyond science, WASP-76b carries a symbolic power. It reminds us that the universe is not made only of places like Earth. There are planets that defy comfort, beauty, and life as we know it. And yet, they still belong to the same cosmic family we are part of. In short, WASP-76b is more than just another exoplanet. It is a reminder of the universe's limitless imagination, a burning titan locked in eternal day and night, where iron itself rains from the sky. And in the chapters ahead, we'll dive even deeper into how this phenomenon actually works. The location and distance in relation to Earth. WASP-76b is not hidden in the farthest reaches of the universe, but it is still far beyond any possibility of direct exploration. It lies about 640 light-years away from Earth, nestled within the constellation Pisces. To grasp that distance, imagine traveling at the speed of light for more than 6 centuries. Only then would you reach its orbit. The concept of a light-year itself is hard to comprehend. Light, moving at nearly 300,000 kilometers per second, takes 8 minutes to reach Earth from the Sun. Yet WASP-76b is 640 years of light away, which means we are essentially observing this planet as it existed centuries ago. In cosmic terms, it is both incredibly close and unimaginably far. Its host star, around which it orbits, is similar to our Sun but slightly hotter and larger. This makes WASP-76b's environment even more hostile, as the planet receives far more energy than Earth does from the Sun. Its close orbit amplifies this effect, exposing it to unrelenting radiation. From Earth, this exoplanet is invisible to the naked eye. Even with telescopes, it cannot be seen directly. Instead, astronomers detect it through indirect methods, such as observing how the planet blocks a fraction of starlight as it passes in front of its star, a technique known as the transit method. This incredible distance means that, for now, WASP-76b is only a world of data, numbers, and imagination. Yet the fact that we can study it in such detail shows how far our technology has advanced. Telescopes orbiting Earth are now powerful enough to peek into the atmospheres of planets hundreds of light-years away. The planet's placement in Pisces may sound poetic, given the constellation's connection with water in mythology. Ironically, though, WASP-76b has nothing resembling rivers, lakes, or oceans. Instead, its weather is more like a blacksmith's forge, with molten metal where we would expect rain. Astronomers are particularly fascinated by planets within this range, because they strike a balance between being close enough to study, but far enough to remain mysterious. WASP-76b's distance makes it an alluring target, feeding both scientific inquiry and public imagination. Its position in the night sky reminds us of how vast the universe is. Even in a region of the heavens that appears empty, entire worlds exist, each one stranger than the last. WASP-76b is a perfect example of this cosmic truth. To look at Pisces and imagine an iron storm raging 640 light-years away adds depth to the starlit sky we see. Every point of light may hide something equally bizarre, waiting for human curiosity to uncover it. And with every discovery, we redefine what we think a planet can be. Thus, WASP-76b's location is not just a scientific coordinate, it is a portal to wonder. It is a reminder that no matter how advanced we become, the universe always holds mysteries just out of reach, daring us to chase them. the extreme temperatures that make the planet unique. If one thing defines WASP-76b, it is heat. Heat beyond the imagination of even our most extreme earthly environments. On the day side of the planet, temperatures soar above 2,400 degrees Celsius, enough to vaporize metals like iron. This makes its atmosphere less like air and more like a blazing soup of elements. To put this into perspective, the surface of Venus, the hottest planet in our solar system, reaches around 465 degrees Celsius. The hottest lava flows on Earth reach about 1,200 degrees. WASP-76b makes both look cool by comparison. It is a living inferno where physics itself feels distorted. The eternal day side acts as a giant furnace, bombarded by the unrelenting radiation of its nearby star. Meanwhile, the night side, though relatively cooler, still maintains staggering temperatures. Even in this shadowed hemisphere, heat lingers at around 1,400 degrees Celsius, a level at which metals condense but never truly freeze. This contrast between eternal day and eternal night fuels the planet's most astonishing phenomenon: the metallic weather system. The cycle of vaporization and condensation of iron happens only because of this extreme thermal split across its surface. Without it, the iron storm would not exist. The atmosphere behaves unlike anything on Earth. Instead of water vapor rising, condensing, and falling, here metals themselves are part of the weather system. It is as if the very materials we use to forge swords and machines on Earth have been transformed into clouds drifting across alien skies. Such heat also reshapes our understanding of chemistry. On Earth, iron is solid and stable, a foundation of construction and industry. On WASP-76b, it evaporates and flows like mist. The laws of matter are the same, but the environment pushes them to their extreme edges, creating conditions that seem otherworldly. The winds generated by these temperature differences are equally astonishing. Some estimates suggest they may reach thousands of kilometers per hour, faster than any storm ever seen on Earth. These winds ferry the vaporized metals from the star-facing side to the cooler night side. For scientists, WASP-76b acts like a natural laboratory, demonstrating what happens when a planet is subjected to unimaginable heat. Each observation helps refine models of atmospheric physics and chemistry, extending knowledge beyond our solar system. This level of intensity makes WASP-76b an invaluable subject of study. By observing its fiery climate, astronomers gain insight into how planets evolve under conditions so different from our own. It is a reminder that the universe is not uniform. Its worlds are as diverse as imagination itself. Ultimately, the planet's temperatures are not just numbers. They are a window into extremes that test the limits of science. They remind us that what feels impossible on Earth is not only possible elsewhere but happening right now, beneath alien skies of iron and fire. The phenomenon of iron rain. Explained by science. At first glance, the idea of rain made of molten iron feels like pure science fiction. Yet, on WASP-76b, it is not just possible, it is inevitable. The process begins on the planet's blistering day side, where temperatures are so high that metals like iron turn into vapor, much as water evaporates on Earth. This vapor, carried by supersonic winds, drifts across the atmosphere toward the perpetual night side. There, the temperature drops significantly, though it still remains hotter than most earthly furnaces. This drastic change in conditions forces the vapor to condense back into liquid form. Instead of forming gentle droplets of water, however, the condensation produces beads of molten iron. These droplets grow heavier and eventually fall from the skies, creating a downpour unlike anything our world has ever experienced. On Earth, rain nurtures life. On WASP-76b, rain would melt through steel. Scientists describe this process as an iron cycle, mirroring the water cycle we know so well. But where our cycle involves oceans, rivers, and clouds, WASP-76b's involves furnaces of metal, vaporized elements, and deadly showers. It is the same principle, but on a scale of intensity that defies belief. The iron storm does more than create a bizarre spectacle. It actively shapes the atmosphere, redistributing energy and elements across the planet. These processes, though violent, are essential to understanding how the planet maintains its extreme balance between night and day. Observations of this cycle come from detailed spectroscopic analysis. By splitting the light from the planet's star as it filters through the atmosphere, astronomers can detect the unique fingerprints of elements present. Iron's signature was unmistakable, confirming that the planet truly rains metal. This discovery has not only fascinated the public, but also reshaped scientific models. It proved that weather, as we define it, is not confined to Earth-like conditions. Weather is a universal phenomenon, adaptable to whatever substances exist in a planet's environment. The implications extend beyond WASP-76b. If iron rain is possible here, then other exotic weather cycles must exist elsewhere. Rain made of glass, methane, or even liquid diamonds, depending on the planet's chemistry. WASP-76b is just the beginning. The beauty of science is that it takes something unimaginable and grounds it in reality. What was once the stuff of fantasy is now observed fact, etched into the data collected by powerful telescopes. The iron storm stands as a symbol of the universe's boundless creativity. In the end, the phenomenon is both terrifying and mesmerizing. To imagine iron falling like rain is to glimpse the strangeness of creation itself, a reminder that the cosmos operates on levels both alien and awe-inspiring, far beyond the limits of human expectation. The role of the nearby star in creating this surreal climate. At the heart of WASP-76b's extreme environment lies its close relationship with its host star. Unlike Earth, which maintains a safe distance from the Sun, WASP-76b orbits so close that it is essentially locked inside a permanent furnace. This proximity is the single greatest factor behind its bizarre climate. The star itself is slightly hotter and larger than our Sun. Its energy output is immense, and because WASP-76b orbits in just 1.8 Earth days, the planet is constantly bombarded with radiation. It is this unrelenting exposure that raises temperatures to the point where iron can evaporate in the atmosphere. The tidal locking of WASP-76b is another consequence of its tight orbit. One side of the planet forever faces the star, absorbing the brunt of its fury, while the opposite side remains in perpetual darkness. This creates the sharp temperature gradient responsible for the iron storm. If the planet orbited farther out, the conditions would be vastly different. Iron would remain solid, and the unique metallic rain would not occur. It is only because of the exact balance between the star's heat and the planet's position that this weather cycle exists. Comparisons to Earth highlight the danger of such closeness. Our planet sits in what is known as the habitable zone, where conditions allow liquid water to exist. WASP-76b, in contrast, resides in what might be called the infernal zone, where temperatures strip even metals of their solidity. The gravity of the star also plays a role. Its pull shapes WASP-76b's orbit and contributes to the planet's tidal locking. Over time, this constant gravitational influence has frozen the planet into its eternal day and night split, amplifying the already harsh conditions. From a scientific perspective, this star-planet relationship provides invaluable data. It demonstrates how proximity to a star can drastically reshape a planet's atmosphere and surface conditions, far beyond what we observe in our own solar system. This makes WASP-76b a natural laboratory for studying star-forced weather. It is a vivid example of how the cosmos creates climates that would be unthinkable on Earth, but perfectly natural elsewhere. The planet shows us that weather is not universal, but relative to each world's unique environment. Without its star's overwhelming presence, WASP-76b would not be the inferno it is. The metallic storms, the extreme winds, and the iron cycle itself are all born from that relationship. In a sense, the star is not just a light in the sky. It is the architect of the planet's nightmares. Thus, the host star is not merely a backdrop to WASP-76b's story. It is the driving force behind every bizarre and terrifying phenomenon that makes this world one of the strangest ever discovered. Without the star's relentless energy, there would be no rain of fire. How scientists detected this phenomenon. The discovery of iron rain on WASP-76b was not the result of imagination, but of cutting-edge technology and scientific rigor. Astronomers used spectroscopic analysis to study the planet's atmosphere, a technique that breaks down light into its component colors, much like a prism does with sunlight. Each element leaves a unique signature, and in WASP-76b's case, iron's fingerprint was unmistakable. This method works when the planet passes in front of its host star, a process called a transit. As the starlight filters through the planet's atmosphere, molecules and atoms absorb certain wavelengths. By examining which wavelengths are missing, scientists can identify the elements present. In this way, even a planet hundreds of light years away reveals its chemical secrets. The data showed iron vapor on the day side of the planet, but not on the night side, a clue that something dramatic was happening. The most logical explanation was that the vaporized iron condensed as it crossed into cooler regions, falling as rain. This deduction became one of the most groundbreaking discoveries in exoplanetary science. The European Southern Observatory's Very Large Telescope, VLT, located in Chile, played a key role in confirming this phenomenon. Its instruments are sensitive enough to detect even trace amounts of metals in distant atmospheres. Combined with other observatories, it provided a detailed picture of WASP-76b's bizarre weather system. One of the most remarkable aspects of this discovery is how indirect it is. No telescope has seen iron rain falling, but the data converges so perfectly that the scientific community overwhelmingly accepts it as fact. It is a testament to the power of modern astronomy that such conclusions can be drawn from faint signals of light. This breakthrough also highlights the importance of collaboration. Scientists from multiple countries work together, pooling data and expertise to reach a consensus. The global nature of the research mirrors the global curiosity that such discoveries ignite. It also shows how far we have come in just a few decades. Only 30 years ago, the existence of exoplanets was speculative. Today, we not only confirm their presence, but also probe their atmospheres, identifying bizarre weather patterns that seem straight out of fantasy. The discovery of WASP-76b's iron rain proves that science thrives on curiosity and persistence. By asking bold questions and building ever more powerful tools, humanity extends its reach into the cosmos. Each breakthrough paves the way for the next. This detection is more than a scientific milestone, it is a philosophical one. It shows us that even worlds so alien can be understood with patience and ingenuity. The iron storms, terrifying though they may seem, are no longer just mysteries. They are knowledge. And with this knowledge, scientists continue to refine their models, preparing to study even stranger worlds. WASP-76b was only the beginning, a gateway to an entirely new class of discoveries waiting among the stars. The technologies used to observe exoplanets like WASP-76b. The study of WASP-76b and worlds like it would be impossible without the technological marvels humanity has developed. At the forefront of this quest are telescopes, both ground-based and space-based, which extend our vision far beyond what the human eye can see. One of the key instruments used was the Very Large Telescope, VLT, in Chile, equipped with advanced spectrographs capable of analyzing light at extraordinary precision. These tools allow astronomers to identify elements such as hydrogen, sodium, and, most impressively, iron in alien skies. In space, the Hubble Space Telescope has also contributed, offering clear observations without the distortion of Earth's atmosphere. Soon, its successor, the James Webb Space Telescope, JWST, is expected to revolutionize exoplanet studies by detecting even finer details in atmospheres, potentially revealing new exotic phenomena. These technologies operate on principles that maximize small variations in light. The tiniest dip in brightness as a planet crosses its star, or the faintest shift in color, becomes a treasure trove of data. It is science at the edge of perception, turning faint signals into profound revelations. The precision required is staggering. Detecting iron vapor across hundreds of light years is equivalent to spotting a single grain of sand glowing faintly on a distant beach. Yet, with instruments finely tuned to cosmic signals, astronomers make the invisible visible. Supercomputers play a crucial role as well, processing vast amounts of observational data. These machines run simulations to model how planetary atmospheres behave, helping scientists match their theories to the evidence collected. Without computational power, discoveries like iron rain would remain hidden in noise. The international network of observatories ensures that no single telescope must shoulder the burden. By combining data from facilities worldwide, astronomers create a mosaic of understanding, each piece adding clarity to the picture. This collective effort mirrors the complexity of the cosmos itself. Technological innovation is not slowing down. Future telescopes, such as the Extremely Large Telescope, ELT, and new space observatories, promise even more astonishing discoveries. With each advancement, the universe grows less opaque and more like a map waiting to be read. These instruments are not just machines, they are extensions of human curiosity. They represent our determination to look beyond our small world, to peer into the unknown, and to transform mystery into knowledge. In the case of WASP-76b, technology transformed a distant point of light into a world of molten storms. And as tools continue to improve, even stranger revelations surely await, hidden in the shimmering skies of other distant planets. Other worlds with equally extreme climates. WASP-76b may be one of the most famous planets with bizarre weather, but it is far from the only one. Across the galaxy, astronomers have uncovered other exoplanets whose climates push the limits of imagination. Each discovery reveals that the universe thrives on diversity, crafting worlds more exotic than fiction could invent. One such planet is HD 189733b, often called the glass rain planet. On this world, temperatures are so high and winds so fierce that droplets of silicate condense into shards of glass, which then rain sideways at thousands of kilometers per hour. It is a storm both deadly and dazzling, as if the skies themselves were made of shattered crystal. Another example is Venus, right here in our solar system. While it does not rain iron or glass, its clouds are made of sulfuric acid, and its surface temperature is hot enough to melt lead. Its crushing atmosphere and perpetual storms make it one of the most hostile planets near Earth. Then there is Kepler-10b, a world so close to its star that its surface may be covered in lava oceans. Instead of continents and seas, it may resemble a sea of fire, where molten rock endlessly churns under extreme radiation. Its existence challenges our understanding of solid planets. Some exoplanets orbit two stars, like Kepler-16b, evoking comparisons to Tatooine from Star Wars. Imagine standing on a surface where two suns rise and set, painting the skies with double shadows. The climate on such a planet would fluctuate wildly, shaped by the dance of dual stars. Jupiter and Neptune in our own solar system also hide violent weather. Jupiter's Great Red Spot is a storm larger than Earth that has raged for centuries, while Neptune's supersonic winds sweep its atmosphere at unimaginable speeds. These storms, though less exotic than iron or glass rain, are no less impressive. The diversity of these extreme environments teaches us that Earth is the exception, not the rule. The comfortable balance of air, water, and temperature we enjoy is rare, perhaps even precious. In contrast, the majority of planets discovered so far exist under conditions that are utterly inhospitable to life as we know it. For astronomers, each strange world is a puzzle piece. By studying them, we gain insights into the laws of physics, chemistry, and planetary formation. The universe is not limited to Earth-like templates. It experiments endlessly with its creations. WASP-76b, with its iron storms, may seem extreme, but it is part of a cosmic gallery of extremes. From glass shards to lava oceans, the weather across the galaxy reminds us that nature's imagination far outpaces our own. In the end, these planets are not just curiosities, they are laboratories. Each bizarre climate adds depth to our understanding, showing that the universe does not adhere to simplicity, but thrives in complexity and wonder. The importance of studying exotic exoplanets for science. At first glance, one might wonder why scientists devote so much time and resources to studying worlds like WASP-76b. After all, these planets are uninhabitable, hostile, and far beyond our reach. But in reality, they play a crucial role in expanding our knowledge of the universe and our place within it. Studying exotic exoplanets helps refine our models of planetary formation. By observing how these worlds behave under extreme conditions, scientists can test theories about how planets evolve, migrate, and interact with their stars. WASP-76b with its iron storms, reveals possibilities that would never be considered from Earth alone. These studies also shed light on the diversity of planetary systems. Our solar system may feel like the standard model, but discoveries prove it is anything but typical. By cataloging strange exoplanets, we understand that the universe produces far more variety than previously imagined. Exoplanets also act as natural laboratories, allowing us to see physics and chemistry pushed to their limits. On Earth, we cannot create environments hot enough to vaporize iron in an atmosphere, but WASP-76b does so naturally. Observing such places helps us understand how matter behaves under extreme conditions. Moreover, studying exotic exoplanets provides context for the search for habitable worlds. By contrasting deadly worlds with potentially life-supporting ones, astronomers learn to identify the factors that make planets like Earth unique. Each hell planet indirectly teaches us more about what makes Earth livable. There are also technological benefits. The challenges of observing distant, hostile worlds drive innovation in telescopes, instruments, and computational models. In striving to study WASP-76b, we advance the tools that will one day help us study Earth-like exoplanets with even greater precision. These discoveries also inspire the public. Tales of iron rain, glass storms, and lava oceans capture the imagination, sparking interest in science, astronomy, and exploration. In this way, exoplanet research bridges the gap between cutting-edge science and human curiosity. Some might argue that studying uninhabitable worlds is pointless, but history proves otherwise. Time and again, impractical research has yielded breakthroughs in understanding, leading to technologies and insights with unforeseen value. Exotic planets may hold keys to knowledge we cannot yet predict. On a philosophical level, studying these worlds humbles us. It shows that Earth is not the center of creation, but one rare island in a vast sea of extremes. It broadens our perspective, reminding us of how precious our fragile world truly is. Ultimately, WASP-76b and planets like it are not distractions from the search for life. They are essential steps in the journey. Each extreme discovery adds a brushstroke to the grand cosmic portrait, painting a universe richer, stranger, and more awe-inspiring than we ever dreamed. Possibilities or not of life in such hostile environments. Whenever scientists discover a new world, the question of life inevitably arises. Could anything survive in a place like WASP-76b? The answer, at least based on what we know about biology, is almost certainly no. Its environment is so extreme that even the most resilient life forms on Earth would be instantly destroyed. Temperatures above 2,400 degrees Celsius leave no room for biological molecules as we know them. Proteins, DNA, and even the simplest building blocks of life cannot withstand such heat. Instead of an ocean teeming with organisms, WASP-76b's skies are filled with vaporized iron, a landscape utterly hostile to life. Even extremophiles, the so-called hardiest organisms on Earth, could not survive. These microbes thrive in boiling springs, acidic lakes, and radioactive environments, but none could endure molten metal rain. The boundaries of terrestrial life stop far short of WASP-76b's furnace. However, science always leaves room for the unexpected. While WASP-76b is not a candidate for life as we know it, it expands our imagination about what might be possible elsewhere. Could life take forms that do not rely on carbon chemistry? Could there be beings that thrive in plasma-like states or exotic chemical systems? These questions highlight why studying extreme worlds is valuable. They remind us that life is not a single formula, but a spectrum of possibilities. WASP-76b may be inhospitable, but it forces us to consider life in environments we once thought impossible. Moreover, by ruling out life on planets like WASP-76b, scientists can refine their search elsewhere. Knowing what environments cannot support life helps narrow down which planets might, saving valuable time and resources. Each no brings us closer to finding a yes. There is also a symbolic value. WASP-76b's hostility contrasts sharply with Earth's comfort, making us appreciate the rarity of our blue planet. The iron rains, eternal day, and scorching heat underscore just how unusual and fragile our world is. For now, WASP-76b is best understood as a natural wonder, not a cradle of life. It is a spectacle of physics, not biology. Yet its existence shapes our quest, reminding us that the search for life is not just about finding where it is, but also where it cannot be. Ultimately, WASP-76b teaches us humility. The universe is vast and full of extremes, and not every world is meant for living things. But even lifeless, these planets still enrich our knowledge and deepen our sense of awe at the cosmos. In the end, WASP-76b may never host creatures or civilizations, but it still plays a vital role in humanity's story, showing us the limits of life as we know it and daring us to expand the boundaries of imagination. Humanity's fascination with cosmic mysteries. WASP-76b stands as one of the most bizarre discoveries in modern astronomy, a world where iron rains from the sky, where eternal day and night battle across its face, and where heat turns even metals into mist. It is a place that feels like a nightmare forged in fire, yet it exists quietly, 640 light-years away. Its discovery reminds us that the universe is stranger than we ever imagined. Each new exoplanet challenges the boundaries of science and creativity, showing us climates and phenomena we never dreamed possible. WASP-76b is not alone. It is part of a cosmic gallery of extremes. Yet the value of such worlds lies not just in their spectacle, but in what they teach us. By studying them, scientists refine their models of planetary formation, improve their instruments, and sharpen their understanding of life's fragile requirements. Every bizarre storm is also a lesson in cosmic truth. For humanity, these discoveries ignite curiosity. They inspire questions about our place in the universe and remind us that Earth, with its gentle rains and balanced climate, is a rare sanctuary. The more hostile worlds we uncover, the more we appreciate the delicate balance that sustains us here. WASP-76b also symbolizes resilience and exploration. Even when direct observation seems impossible, science finds a way, through light, data, and imagination, to unveil the secrets of distant planets. Each breakthrough proves that no mystery is beyond human reach, given time and persistence. There is a poetic element, too. To think of iron falling from alien skies is to glimpse the artistry of the cosmos. It shows us that the universe is not just functional, but creative, crafting worlds that shock and inspire in equal measure. In a sense, WASP-76b is not just an exoplanet, it is a mirror. It reflects back our curiosity, our hunger to explore, and our determination to push beyond the limits of what we know. Its storms exist not only in space, but in the imagination of those who dare to study it. The story of this planet is not finished. Future telescopes like the James Webb Space Telescope will reveal even more details, perhaps exposing mysteries beyond iron rain. Each new discovery will add another chapter to this tale of fire and storm. But for now, WASP-76b remains one of the most iconic examples of the universe's strangeness. It is a reminder that, out there among the stars, reality often outpaces fiction. The cosmos is not bound by our expectations, it writes its own rules. And as long as humanity continues to look upward, planets like WASP-76b will continue to feed our greatest gift, the endless curiosity that drives us to explore the mysteries of space.